Okay, so we have the arc xy such that the angle is xyz is equal to theta. Show that the perimeter P units and area A square units, okay, of the triangle are given by blah blah blah. Okay. Show that the perimeter P units and the area A units. Okay, so you're supposed to show the following. So let me write that in black color. So you're supposed to show P is equal to 4 square root 3 1 plus sine theta plus cosine theta. Okay, and area is given as 12 sine 2 theta. Okay, so this is what you need to prove. Okay. Okay, we need to get the parameter. So what can we deal with first? Maybe we can find the parameter of the triangle, right? So this is your x, z, and this is your y. So what is x, z? Okay, so that's your O, right? O over A or O over H. Okay, so O over H is x and y. That is equal to sine theta. Do you agree? O over H. O over H. Okay, and this is what you need to find. And xy is given as 2 square root 12. So this is 2 square root 12 sine theta equal to x z. How about the other one, zy? So that's a over h, right? So you have a cosine theta is equal to a, which is your zy over x y. So again, you would have something like that because it's the same as the other one. So I can quickly write it down like this. Okay. Yeah, you're okay with this? Okay, now we need to find the parameter. Parameter is basically what? You add everything. So you got 2 square root 12 plus 2 square root 12 sine theta. Then you have 2 square root 12 cosine theta. You take out 2 square root 12 from everything. You are left with 1 plus sine theta plus cosine theta. This one, I did mention to you, you need to simplify. So this is 4 times 3, right? You always end up with one prime number. So 4 times 3. So 4 square root 4 is 2. So 2 times 2 square root 3. And there you go, you get your final answer. Okay. Now we need to find the area. Okay. Area of triangle. So this is a right angle triangle, so you can have more than one way of doing it. Okay, the more simplistic way is area equal to half times xz times zy, length times breadth. Okay, so this is equal to half times 2 square root 12 sine theta times 2 square root 12 cosine theta. This is equal to, we can take out the square root 12 out and one of the two. Okay, or you can just cancel this like that, also can. So you're left with square root 12 times 2 square root 12 times cosine theta times sine theta. So if I take this, and take this, 12 times 12, sorry, square root 12 times square root 12 is what? 12, right? And then I'm left with 2 sine theta cosine theta. So the final answer will be 12 sine 2 theta. This is for area. So far good? Can follow or not? I cannot see you guys, so you need to just voice out. If I don't hear anything, I take it as it's a go, right? Okay, so I'm going over to the next one. Okay, so now part 2, they want you to express P in the form of blah, blah, blah. Okay, so what you have, this is part 2, try it 21 also. P we already have as 4 square root 3 1 plus sine theta plus cosine theta. But they want you to convert this into something of this. P equal to 4 r sine theta plus alpha. Okay, so this is the end answer that they want. So how do we go about doing it? Okay, you need to times in. Okay, no choice, have to times in. So when you times in, you get 4 square root 3 plus 4 square root 3 sine theta plus 4 square root 3 cosine theta. So if you notice, I'll bracket this up. So I hope you can see that this is one part, this is another part. So the other part is this one, the r sine. Okay. So what I'll focus is I'll be just focusing on converting this into the r sine theta plus alpha. Okay. So this one remains the same, no change. I'll just change this. So we have 4 square root 3 squared, square both, square root. This is your r, and then you have your sine theta. Since it's a plus, this is also a plus because it's sine. This one, b over a, is actually tangent inverse 1. So what is this? What is tangent inverse 1 now, guys? 45, right? Okay, so that will become, if you simplify this, you should get 4 square root 6. Okay, the r value is 4 square root 6 sine theta plus 45. There you go. Done. Any questions? Anybody need time to think or to ask question? Guys, this is my last session with you, more or less. Okay, So please make best use of it. Please ask questions if you don't know. Okay. Okay, no questions. Then we move on to question number part 3. Okay, part 3. Find the value of A when P is equal to 14.5 and the theta is between 45 and 90. So they want you to work from the value of P itself. Yeah. So you need to find the theta when P is equal to 14.5 and then substitute the theta value back into A. Okay, so that's what you are supposed to do. So 14.5, right? Yeah, that is equal to 4 square root 3 plus 4 square root 6 sine theta plus 45. Okay, so you must move this first. So just do step by step. Minus 4 square root 3. This is the first times. Okay, this is divided by, sorry, divided by 4 square root 6, because I need to push this, sorry, push this over to the other side. So that will give me sine theta plus 45. Okay, so that is approximately, from what I see, you should get this approximately lah. Sine theta plus 45 degrees. Okay, so when you do the inverse, you get this as 50.6 degrees. So when you take this off, minus off 50.6 with 45, you get 5.606. Now, this is where you need to substitute into what? The A. The A is equal to 12 sine 2 theta. So 12 sine 2 theta is 5.606, about there. Okay, that should give you 2.33. Okay, no questions. So if you notice, I don't know whether you saw a pattern so far. The pattern for this is always to look for right angle triangle. Usually the pattern is to look for right angle triangle. And using the right angle triangle, you take the cosine or sine and you manipulate those figures and you should get your perimeter or your area. Okay, that is some. Okay, so it's already 2:30, so I think we better go through just one more example. 11. Okay, so I won't go through the 13 or 14 now. So go through question number 11. Okay, take a look at question number 11. You have your diagram, right? Please look through that. I'll try my best to draw this out. Hope you have already read, huh? So you're supposed to explain why BC is equal to 5 sine theta plus 11 cosine theta. BC. So in order to find BC, BC is a straight line now, although my drawing doesn't look like a straight line, but it is a straight line. So you need to find what is BF, and you need to find what is FC. In order to find BF, you need to find AE. Okay, so this is the same as AE lah. Okay, so AE, you can draw this out. This is A, this is E, this is 5, and this is your theta. So you want to find AE, this is your O over H. So sine theta is equal to AE over 5. So 5 sine theta is equal to AE, which is also equal to BF. Okay, next, this one is also easy. So this is FC. We're given this as 11 cm. So if you draw this out, if you take this as F and sorry, C and F, C and F is you have this one here, theta here, and this is 11 cm. This is your D. Okay. So same thing here. You need to find what is your FC. So this is your A and H. So it's cosine theta equal to FC over 11. So FC is equal to 11 cos theta. Therefore, BC is equal to BF plus FC. So BF is 5 sine theta plus FC is 11 cos theta. So you have proven this already. Okay. Explain why the perimeter PCM of the quadrilateral is given by this quadrilateral of P. 1, 2, 3, 4. Okay, so they are taking the whole quadrilateral. Okay, so the whole thing, so you already know what is BC already. Do you know what is AB? Or do you know what is, yeah, you need to know what is AB. So that's something that you need to find. Hmm. For that, I think you need to minus off FD minus DE to get your EF. Okay, so what is AE? Sorry, not AE, DE. So you need to find what is your DE, this one. So DE is A, right? So A over H is equal to cosine theta. So this is equal to DE is equal to 5 cos theta. Okay, next we need to find what is DF. DF is given here. DF is again no, it's O. O over H. O over H is 11. So sine theta is equal to O over H. So we bring this over. DF is equal to 11 sine theta. Okay, so you need to minus off to find your AB. So AB is equal to DF minus DE, which is 5 cos. Of course, what you want to find is perimeter, right? So perimeter is given as this is 5. So 5 plus 11 plus what is FC? FC, sorry, BC. BC is given 5 sine theta plus 11 cos theta. Okay, plus your AB. AB is 11 sine theta minus 5 cos theta. That will give me 16 plus 16 sine theta. That should be plus 6 cos theta. Is that what you are supposed to find? Or is it? Yeah. Yes. So perimeter found. Okay. The next part is they ask you to find okay, so this is part 1 so that you know what's going on. This is part 2. This is also part 2. This is part 3. Okay. So part 3, find the value of theta when t is equal to 30. So 30 equal to 16 plus 16 sine theta plus 6 cos theta. So you minus off, what do you get? 14. 16 sine theta plus 6 cos theta. So what do we do over here, guys? So they indirectly want you to use the R formula here already. You get the hint. There's no other way of solving this, huh? Okay, so you need to find your R, which is 16 squared plus 6 squared, whole thing square root. And it's sine theta. Because they never say what you want to use, so you can just use sine theta here for easier reference lah. Okay, and then it's tangent inverse 6 over 16 equal to 14. So still got more things to be done. So can okay, so let me rewrite over here. So what we found earlier was R is equal to 16 squared plus 6 squared. This should give you square root 292. And then tangent inverse 6 over 16, your alpha. So alpha is equal to 20.6. Okay. Okay, and we got earlier on the answer was 14, right? So 14 equal to 292 sine theta plus 80.6. So this is where we ended off from the previous slide. So bring this over, become 14 over square root 292 equal to sine theta plus 20.6. The rest is all just standard way of calculation. Find your alpha first, basic angle or reference angle. That should be I think 55.0 degrees. Okay. Since this is positive, so it must be in first quadrant or second quadrant. So theta plus 20.6, okay, is equal to 5 or okay. In this case, theta should be an acute angle. Okay. Um, I don't know whether have you noticed. That's why I stopped over here. I didn't calculate for the obtuse angle because the theta here and the theta here is within the 90 degrees. Are you with me? So it should be an acute angle. So based on that, right, you don't need to calculate the second quadrant. Just the first quadrant is sufficient. Can? Okay, so theta is equal to 55 minus 20.6. I think you should get 34.4 degrees. Yeah.
Mr. Silver,
Yes.
I thought it's 16 sine theta plus 6 cosine theta equals the square root 292 sine and the bracket.
Slow down. Sorry, again.
I thought
16?
it's 16 sine theta plus 6 cosine theta equals to the square root 292 sine theta plus 20
Yeah, correct.
plus. So
Yes, correct. I already, earlier slide, I already minus off the 30 minus 16 already, what? Is this what you're asking me?
yeah.
Yeah, I already minus off already. Can you see this? This is my,
Oh, okay, I get it.
okay, so yeah, I already minus off. That's why I get 14 lah. Then?
Okay.
Okay. Okay, so the fourth question, this is third. So the fourth one is they ask you for the maximum value of P. So how do we find the maximum value of P, guys? Let me recap. What is P equal to? 16 plus 292 square root sine theta plus 20.6. Correct? When this hits a maximum value, what would this become? It should become 1, correct? For minimum value, it become minus 1. For maximum value, is just 1. So the maximum value is 16 plus 2 square root 1. That's it. I think based on the textbook answer, it should be this one. Check. Okay. But of course, they do ask you find the value, not only this one, but also the corresponding, theta value also. So how can I find the theta value? Simple. This is exactly what I've been doing, right? So I just equate this to be 1, no? So sine theta plus 20.6 equal to 1. So theta plus 20.6 is equal to sine inverse 1. When do you get sine inverse 1? When you get 90 degrees, right? That's your highest point, correct or not? Then do you understand or not, guys? So theta is equal to 90 minus 20.6, which is equal to 69.4. For you to recap, if not, try to draw the sine curve again. This is 90 degrees when you hit maximum 1, and that's the only one value. Except for cosine. Cosine got two values, 0 and 36. Okay, then are you with me?
Yes.
Okay, I'll let you do one other question yourself. I don't know what question I chose. Is it 13? I think I chose 13 for you because got so many sign. So I would have chosen something that is cosine. Well, you can try 13. If you have questions or if you don't know how to do, then I can give you the answer for it. Then, okay, so it's almost 45 minutes over already. So I have another 45 minutes to go through the applications of trigonometry. Okay, so this one I'll save as PDF. Okay, I'll send you shortly. Okay, so let's move on. Stop my share. Just hold on. Okay, if you have your textbook, then you may want to check on page number 296. Sorry, 297. Okay, my ebook is still uploading now, so take a look at the first portion, the top, where they describe about amplitude, period, and axis of curve. Hope you remember that. Okay, it's still taking some time. Okay, I want you to read the example number 22 first. Can you please help me read the example number 22? The rotational motion, the bottom of a Ferris wheel with a radius of 10 meter is 1 meter above the ground, and the Ferris wheel makes one complete revolution every 40 pi, okay, seconds. The capsule is initially at point X. Okay, it's initially at point X. Okay, on the Ferris wheel as shown in the diagram. Find the trigonometric trigonometric equation to model the height of the capsule of the ground as a function of time. Okay, so basically for application of trigonometric functions, right, you encounter only two functions, sine and cosine. Okay, you will never ever encounter tangent at all. Okay, sine and cosine are more frequently being used. And for sine and cosine, you have this model where it can be both positive or it can be negative. So it depends on how the curve starts. Does it start from your zero? Does it start from axis of your curve and then move up and then move down? Or is it from the axis of curve, it moves down and then it goes up, you know? So there are a few options with my, okay, I have to restart my app. It's not working. Yeah, let it run while I will describe. Let me rerun this. Okay, so I'll just share my whiteboard. Let me just go through with you. So typically in your exam, there's only two types of function that you'll ever come across. You'll be asked to do this, or you'll be asked to do this. Okay, but typically, usually your graph would be, you know, this is the normal kind of graph for positive lah, for positive cosine, and for positive sine, you get something like this. Okay, I'm talking about very typical graph. But you may also get graphs which are like this and like this. Okay, so what I'm trying to say is that there will be circumstances where this will become your negative r sine theta plus alpha. Do you get what I mean or not? And this is negative r cosine theta plus alpha. Yeah, I hope you get this idea. This is the four typical graphs that you ever come, or four different scenarios that you ever come across. Okay, Kana. Okay, so let me just go through example. Wait, is it working? It takes time. Okay, let it run for a while. Meanwhile, I'll just explain through my whiteboard. That's my whiteboard. Okay, so let's say you have a Ferris wheel. Okay, now, so they say the radius, that means from here to here is a different color. From here to here is 10 meter. So here to here is also 10 meter. Okay, so total is 20 over here already. And then they say it's 1 meter above the ground. So this is 1 meter lah. So total maximum height you can reach is what? 21. So the maximum height is 21. The minimum height is 1 meter. Do you understand this portion, guys?
Yeah.
Okay, so what I'm going to do is I'm going to draw the height. So let this be 21. Let this be 1. Okay, this is of course 0 lah. Can you see the height? So this is height versus time. Okay, I'm just bringing you through it. So here you have 10 meter from here. So this is 11. So this is 11. This is your axis of curve. Remember I talked about axis of curve. So what has happened? So it has moved up by 1 unit lah. So it's now from so it has moved up by from instead of 0, right, now has moved up almost by 11 already. Okay, has moved up by 11 units up. Okay, supposed to be 0 lah, but now has moved up to 11. Okay, so this is one thing. So if you plot your graph, it'll look something like this, where you have a different color. So it may move like this, this, and like this. Okay, of course, from here to here is one complete revolution lah. This is 40 pi seconds. Why do I say 40 pi seconds? Because it's one complete revolution or one complete cycle lah. You understand? Because this is a basic concept. So you need to understand the context of the question in order to get the period, the amplitude, and the axis of curve. Are you with me? Okay, so let's work out the period. What is period? So period for sine and cosine is always 2 pi over b. Tangent is just pi over b. Yeah? So cosine and sine is 2 pi over b. But you already know this is 40 pi, right? So what is b then? So 2 pi over 40 pi, 1 over 20. So this one is very important. Huh? This is very, very important. Okay. So what else do we need to know about more about this? You know that this is typically a sine. So y is equal to so you know that y is equal to a sine b pi. Okay, usually this is what we write plus c. Okay, sorry, not pi, it's t because it's seconds, right? So we know a. A is what? A is from here to here. A is your amplitude. So your amplitude is how much? Guys, what is your amplitude? 10, right? Amplitude is 10. Okay. 21 minus 11. Also, that way also can. Or just take into consideration the radius also is 10. And sine B is now 1 over 20. And what is this? This is your axis of your curve, correct or not? Which is 11. No? 10. Nice. Are you comfortable with this? And this is your trigonometric equation for how the wheel spins from X all the way to the rest. So it goes from here. If you notice, this is the point X here. Then as it moves up, it reaches the maximum point, which is here. And then it moves down back to X. So this is back here again. Then it moves further down to the lowest point, which is over here. And then it moves back to the X again. Can you see the point? How it moves around? Guys, are you all comfortable with this?
Can you explain the A part?
The A part. A means amplitude, correct or not? Amplitude means what? From the rest point or from the axis of curve all the way to the trough or to the crest. This is called crest, the highest point. The lowest point is called trough. So it's always from the axis of curve all the way to the highest point or to the lowest point. It's called your amplitude. Okay, and if not, you can always use this calculation lah. Yeah. You can use this calculation. A is equal to the highest point. What is the highest point? 21. Okay, 21 minus the lowest point, which is 1. Then always divide by 2. Highest minus lowest divide by 2. It will always give you my amplitude also. I take the highest 21 minus the 1, 20 divided by 2. I get my amplitude lah. Understand?
Yep.
A means amplitude, B means period, C means what? The axis of curve. Understand? It refers to the number of cycles. Okay, Cam?
Yep. Can move on.
Okay, so I think we shall do this first because it has diagrams, so I guess it's easier for you to understand lah. Okay, can I get you to look at example number 24, guys? Example number 24. Is it a sine curve or cosine curve based on the curve that you see there? Page number 299. The graph you get is like this. This is what they
Is it a
draw for
cosine
you.
graph?
Yeah, it is a cosine graph, but not typical cosine graph.
It starts
This,
from negative region.
yes, correct. So usually your cosine curve, this is a normal cosine curve is like this, correct or not? This is cosine theta lah. This is your normal curve. But now what you have is like this. So this is the negative cosine theta. Understand? And cannot? Can. Okay, so this is oscillation that I was talking to you about. So one of the typical example is this one. This is one of the questions that Mr. Lim said for last year. If you do get the paper, you can check for Sec 4 last year. He had this where it's like a baby cradle that will move down, up and down. Okay, so that will form an oscillation as well. Another type is the pendulum. Okay, pendulum is another type. Also the clock, the minute hand or the hour hand of your clock. Okay, as it moves around the circle, you'll also make a sine curve. Okay, if you notice. Okay, so all this is possible. Okay, so let's look at the details of it. A mass attached to the spring is pulled down to position C. So it's pulled down from the rest position. The rest position is B lah. This is the rest position, but it has been pulled down to C. Since it's being pulled down because of the elastic nature of the spring, right? It will what? Move up and down. So this is A, this is B, this is C. Okay, so it's also released from the position B. Okay, C from its position B and then release. The mass will bob up to position A. Assuming the mass never loses any energy or momentum, It'll oscillate up and down between A and C, given that C is the initial position of the mass. The change in position, blah, 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 can be modeled after this one. Okay, so in this question, they already give you the model. But in the earlier example, you need to find the model first. That is more typical. If they give you like this, right, it's a giveaway question. Usually they like you to model the, find the model, either cosine or sine. Okay, so if they give you this, it will be your lucky day. Okay, if they give you this. Okay, so they tell you this is given, d is equal to minus 5 cos pi over 2 t. Okay. How far is C from B? So from here to here, what is the distance? They're asking you the distance from here to here, which is basically your amplitude. Your amplitude is
5.
5. That's it. Simple, right? Answer. That's part 1. Part 2, they ask you, how long does it take for the mass to go from C to A? Okay, from C goes all the way up to A. They're asking you this one. Okay, so it is not a complete what revolution, right? It's not a complete cycle. What is a complete cycle? You go up and then you come down back. This is considered your complete cycle from here to here. But now they only ask you halfway around only. But you still find the full, but you divide by 2 lah. You get what I mean or not? You still find the period, one whole cycle, one complete cycle. Then you divide by 2 to get the answer. So what is period? So period is 2 pi over b. What is b, guys? 2 pi divided by pi over 2, correct or not? So that's 2 pi divide by pi over 2. So you should get 4. What does this mean? It means you have 4 seconds to complete one cycle. That means C to A, A to C is considered one cycle. C to A, back to C is considered as one cycle, but now it's only halfway only. So just C to A alone will now take how long? 2 seconds. So the answer is just 2 seconds. Are you with me? So far, okay? Part 3. Part 3, they ask you, how far is the mass from B when t is equal to 2.5 seconds? Okay, so you need to find the mass, find the, how far is it? Find how far is it from B. So based on the equation given, d is equal to minus 5 cos, right? So d is equal to minus 5 cos pi over 2. In place of t, you put in 2.5 seconds. Okay, so from your textbook, you should get, okay, you need to simplify. So after you simplify, you get this. Okay, just in case if you're wondering how to convert this into this. you're wondering how can I get here, okay, I want you to track back to what we have been doing all the way. You try to change this to degree first. So in terms of degree, is 5 times 180 divided by 4, which I think will fall in the third quadrant, right? Can someone help me find the answer? 5 times 180 divided by 4. What do you get?
225.
225, thanks. So 225 is from here to here is 225. So what is this? What is your this is 225, right? So this is 180. So 225 minus 180 is what? 45, right? So this angle is 45. Do you understand or not?
Yep.
Okay, this angle is 45 degrees. Okay, if the angle is 45 degrees, then you work out. Okay, you know that it's a special angle, right? Okay, if it's 45, then this one should be 1 and 1. This is square root 2, right? If I'm not wrong. Does it look that way? Okay, what is cosine A over H? Yeah, so this will give me what? Cosine 45 degrees will give me uh, 1 over square root 2, correct? So cos 225 is the same as cos 45 with a negative sign, no? A negative sign. Okay, just remember. Because cos in the third quadrant is always negative, correct or not? Cos in the third quadrant is always negative. The only thing that is positive is tangent. So this one, I times square root 2, I times square root 2, I rationalize it, I should be able to get square root 2 over 2 with a negative. So that's how you get this as positive 5 square root 2 over 2. Do you understand? I'm just recapping the initial function. Okay, then? Okay. The next one is very important, guys. Please put an asterisk sign there. The next one is very important. Part 4. This one is very, very important. Very typical of them to ask you such a question. Okay, what are the two earliest times when the mass is 1 cm above B? So this is what you have, right? This is your B. Now what they want you to do is find 1 cm above. So this is 1 cm above B. They want you to find these two timing. Are you with me? Do you understand what they are trying to find? The two earliest timing when B is above 1 cm. So basically, when you draw this line, what it means is you are D equal to negative 5 cos pi over 2 t, right? You're making this 1. That means you're making this y is equal to 1. You just substitute this so that you got 2, you have a curve and you have a line, then you find the point of intersection. No? Okay, but you get two values. You get two values. So over here, if you work it out, it should be cos pi over 2t equal to negative 1 over 5. Okay, so you find your reference angle Reference angle, you don't include the negative sign, so it's just cos inverse 1/5. I think from your textbook, what did they say? Or you're finding in terms of radian. Okay. So if they are finding in terms of radian, then use your radian mode. Your alpha is equal to 1.3694. Okay. Okay. So where does it fall under now? Okay. You have this as negative 1/5. What does it mean? It means
The
this
second,
is
third quadrant.
very good. Because this is negative, it must be in second and third quadrant. Second quadrant is pi minus alpha. This is pi plus alpha. That's about it. So pi over 2t is equal to, okay, based on your textbook, what they have given is, or they never give you the final answer. So minus 1.3694, and you have another one more value, pi plus 1.3694. So you add these two, and then you bring the this one, the pi over 2 across. When you multiply, that means you have to divide. Whatever answer you get, you must divide by pi over 2. You get this as your answer, 1.13 and 2.87. These are the two earliest timing lah. Now, I want you to hear me very carefully, because this is the tricks and tips that you can gather. Now, what some of the teachers will do is they will not stop here. They will not just ask you for the two earliest timing. They will ask you, how long does it stay above? How long does it stay uh, above the 1 cm above B? So basically, they're asking you for the timing here. This area, how long does it stay? That means you must just take what? You just need to do one more step. One more step. What is the one more step? Take 2.87 minus away 1.13. So they might not only ask you for the time, but they want you to find the difference between the two timings. Understand? Or is it too far-fetched for you already? Guys, are you there? Yes, no? Are you a bit more comfortable with the real life application?
Yeah.
Okay, there's more practice. This is not enough. It's only tip of the iceberg. It is only the tip of the iceberg. There's plenty of examples for you to try out. Okay, got tidal waves, got rotational motion, got climate change, got temperature. I don't know, I don't see any temperature here, but usually they will have a temperature also lah. Climate change, what else? Yeah, projectile motion, sound wave. There got temperature fluctuation and energy as well. Okay, so there are many things over here, but the concept is always the same lah. You don't run away from the concept one. So if you understand these few examples, it should set you on the right path lah. It should set you on the right path. So let me just finish up with one more example. Okay, thereafter I'll let you all try, but you must seriously try one example on your own lah. Okay, from 11.6, you can choose any questions here. Uh, coming in and out. Okay, can we just do the last one? Example 23. Okay, just read. Based on the historical data, the average daily temperature T degrees Celsius of a city in June varies from a low of 24 degrees Celsius at 3 a.m. Okay, to a high of 31 degrees Celsius at 3 p.m. Suppose the average daily temperature temperature in the city can be modeled after T equal to A sine ET plus C. Okay, the T is time in hours after 9 a.m. So this one is reference point, so it's from 9 a.m. In hours after 9 a.m. Okay. Now, so first thing they give you this clue for what? What is this clue for? They give you the lowest and the highest, correct or not? So typically like this, you get what I mean? The highest and the lowest, correct or not? So they tell you the lowest is 24, the highest is 31. So can you tell me what is the amplitude? What was the thing? Highest minus lowest divided by 2. So that will give you 3.5 amplitude. Your A is 3.5. Okay. Now, you need to find what is your B then. Okay. So this is based on a 24-hour, right? So you have a 24-hour. Yeah, just give me a minute. Let me. So 9 a.m. to sorry 3 a.m. to 3 p.m. is only 12 hours, and then back to 3 a.m. is another 12 hours. So total 24 hours. Yeah. I hope you get the point that. Okay. Oh, okay, it's here. So from here to here, the highest to lowest is from 3. Okay, it should be the other way around, but never mind. 24 first. Either way, it should be 3 a.m. to 3 p.m., which is 12 hours only. Okay, so for a complete cycle, you must have 24. This is only half the cycle. So one full cycle is 24 hours. So that's how you get the 24 hours. Okay, so 2 pi over b is equal to your period. Okay, and your period is 24 hour. So 2 pi over b. B is equal to pi over 12. This is your b. Okay, now last but not least, we need to find what is your in between. Okay, the in between the axis of curve between 3 a.m. and 3 a.m. and 3 p.m. You must find the in between the axis of curve. So for axis of curve, you just need to add the 2 points divided by 2. So 31 plus 24. So it's like finding the midway between highest point and lowest point. So this one you get 27.5. So C is equal to 27.5. And then you can put all these together. So it will become T is equal to 3.5 sine pi over 12t, and then you have what?
Plus 27.5.
Yeah, correct. Thank you. 27.5. Yeah. Okay. And yeah, all these are just examples that we have just gone through. You can try it, which is very similar. Okay, very similar to what we have done. I would suggest that we do at least one or two questions on your own. It will take some time, but at least you try to do this on your own. Let me choose something. What would you all want to choose? Number two. Okay, question number two. Very similar to what we have done. Number two. And number five, with some explanation and things to answer lah. Okay. Or you need to sketch circle. I think that will take you a longer time, even more. Okay. I tell you what, why not we do question number five first? Okay. Do question number five first. How long do you need to do this? Ten minutes. Okay. I give you about 5 minutes to try. At least get the working done. At least half the working done. Okay. Yeah. So I'll give you about 5 minutes to do up this first. Okay. How's the progress? Are you all done?
Yeah.
Yeah, okay. So it's between 7:55 and okay, 5:05, not 4:05, 5:05.
Okay.
See why the answer is 7:55, correct? But it should be 5:05.
Okay.
Okay, so let's not waste time. Let's do this. So, I've given the explanation here. So if your height is greater than 4.2, then the boat can move because there's more water. So it won't hinder the movement of the boat. But if the water is less than 4.2, then the boat will not be able to float out. Okay, so that's the issue here. So they want you to substitute t equal to 4. So h equal to 1 point when t equal to 4. So when you get this, you get roughly about 4.49 meter. Okay. So since the height is now greater, 4.2, the boat can leave the harbor or the port safely. Can? Can, huh? Okay, so let me do the next one. This is part 2 now. Okay, part 2, for the boat to re-enter the port safely, you need to have a minimum 4.2. So that's what they are really asking you for. Okay, so basically, um, okay, this is cosine, right? Cosine curve. So it's like this. Okay, approximate lah. Okay, so they are finding this is assuming this is 4.2. Okay, so what is the timing? So they got two timing, right? So this is the two timing that they're asking you for. Okay, so you need to substitute h as 4.2. So 4.2 equal 1.2 cosine 1.6 pi t plus 5. Bring the 5 over, and then divide by 1.2. You get this. I think I left a 0 here. Sorry, there's a mistake. 0.16 pi t. Okay. And you need to find, because this is you have to use radian. Okay, so alpha. Okay, so alpha will be equal to cosine inverse 0.8 over 1.2. Don't put in the negative sign. So this should give you about 0.841. This is alpha. Okay. So this one must be in, because the cosine is negative. Because this is negative, so it should be in second quadrant and third quadrant. Second and third. So you will have 0.16 pi t is equal to pi minus 0.841 and pi plus 0.841. Okay, so you get okay. Okay, so you get, I think you get another one more as well. Wait, let me think. Will there be one more solution? Okay, I'm not so sure, but we'll just try first, can? Okay, so divide by 0.16 pi. 0.16 pi. Okay, so you divide, you should get two, three, two. You can go for one more round. Yeah. So I think you can go for one more round. So you can have pi minus 0.841 plus 2 pi. If you go for another one more round, you should still be within the range. Yeah, you should be still be within the range. Okay, if that is the range, Okay, let me calculate this. What do you get? Okay, you should 17.077. Okay, so all these are in terms of hour. All these are in terms of hour. Okay, so you need to convert them into hours and minutes. There's a simple trick how to convert from hours to hours and minutes. I don't know whether if you can. Do you see this in your calculator? I do remember, but do you have something like this, like hours symbol like that, like a apostrophe symbol or HMSS, something like that? So if you press, you can convert from hours to hours and minutes instantly. Okay, but if you don't know how to do that, then you have to use. Oops, my battery is running. I still have 15%. Okay. Okay, can you just help me to convert? Okay, 4.5768 and 7.9232 followed by 17.077. Okay, and then you minus off. Okay, you should be able to get these two as your answers: 7:55 p.m. and another one as 5:05 a.m. Okay, this one you need to go and check. Can you please help me check? Okay, so please practice your 11.6. If you need answers, do let me know for selected questions so that I can just pass you the answers for those selected questions as well. Okay, from 11.6. Okay, otherwise, finish up your try it 22, 23, and 24. Try it 22, 23, 24 to practice. Okay, I'll finish up uploading all the other videos as well. I'll try to upload the chapter 2 and other chapters as well, whatever I can over the next few days. Okay, so please go and revise for your Amax retest. Okay, if you have to. Yeah. Okay, so that's it, guys. So I'll end my session here and my recording as well. Okay, and I'll send you this thing soft copy.
Mr. Subra.
Okay.
Mr. Subra.
Stop sharing.
Hello. Hello.
Hello.
Hello.
Oops. Anyone speaking? I cannot hear. Hello.
Hello, Mr. Subra. I have a question.
Yes. What is it?
Let me send you.
You're sending me through WhatsApp.
Yep.
Just wait, my WhatsApp is still loading. Oops. What's the question on?
The what's it called?
Okay.
trigo identity.
Okay, you send me trigo identity. Yes. Which one is it? There's 1, 2 here. 7 or is it 8?
Eight.
Huh?
Question 8.
Question 8 I got do eh.
Where? I don't remember.
Yes,
One
I think during one of the consultation, I think
Hmm.
we never record. Okay, I just tell you how it should be done, and then from there it should be. I think you should be able to work on your own.
Okay.
Okay. Wait, let me open my Zoom. Computer is a bit slow today. Okay. So they ask you to prove 3 cosine 3a equal to 4 cosine cube a minus 3 cos a, correct or not? So this one you convert to cos 2a plus a. You remember this or not? Double addition formula.
Yeah.
So this is cos 2a cos a minus sine, sine, oh my god. Okay, I hope.
Oh my god.
His computer
Oh,
died.
he
His
died.
computer died.
Let's go. I'm the host now. Should I make host?
Oh no, it's me. It's me.
Make me co-host, man. Come on. Let me admit Subra.
You know if he come back, right?
Bro, he left.
Yeah, he left. His computer died.
Let's go.
Just don't let him back.
Hey, you can actually mute him.
Host.
You can
Is
mute
it?
Subra. You can mute
No, no.
Subra.
Once he join back, he will become the host again. I will be co-host.
You. Not like I'll be co-host.
You're on PUBG now.
Wow. Let's just hold a Zoom and call, you know.
Yo, Aiden, you on?
Yo, Aiden.
I think he's eating.
What is this, man? What is this? What is this?
I'm
Aiden's
eating.
Aiden's eating.
Where's Mr. Sura?
He's super gone.
You know everything is recorded, right?
Yeah. Hi. I'm on TV. Oh my god. Hi guys. Wait, no, he's not recording or what? He's not here or what? I thought.
If he's not here, it will be stopped with me.
Oh. Stop it. No, but it's not recording what? Oh, it is. Oh. Hi, I'm recording.
His computer died.
No.
Okay, bye-bye. I'm gonna kick people already.
Oi!
Oi. No kick. No. Don't kick, don't kick. Don't kick first.